Alrighty, guys. So this lesson, we're going to talk about something in your book. It's called Optimization with Linear Programming. And that's kind of a long word. And if you want to read about the history of that in your book, you are definitely welcome to. It's actually pretty interesting, but I'm not going to do that in this video because I want to show you the basic steps of how to do this. If you're interested in kind of the history and what it is, I definitely recommend that. But for what we're going to do today is we're going to stick with the math. So -2 less than or equal to x less than or equal to 4. This is the problem that we're going to work with. Y is less than or equal to x plus 2. And y is greater than or equal to -0.5x minus 3. And then we also have this little function down here at the bottom that looks different than what you normally see. We'll talk about that in just a minute. Okay, so we have 3 equations, and this is example 1, and it says, graph the system of inequalities. Okay, we know how to graph. We're going to do that. It says, name the coordinate of the vertices of the feasible region. We're going to talk about what that means and find the maximum and minimum values of the function. We're going to talk about all of that. So first, okay, let's go ahead and get a graph up here. Let's get this large Cartesian plane. That way we have plenty of room to work. It's on my face. Ah, I'm in jail. Okay, no, that's weird. I'll stop. Okay, so we're going to stick this out to the side and we're going to graph this. So x is between -2 and 4. So this one's relatively easy if you remember how to do it. So remember, x, if you have a line like x equals -2, okay, that is a vertical line. So we're going to do that first. So -2 is right here, and we're going to graph this line. Ooh, I did that kind of straight line. Oh my God, my straight lines are so bad. Okay, so that's my x is greater than or equal to -2 and less than or equal to 4. So let's find 4. 1, 2, 3, 4. That's going to be here. Sort of straight line. That one's really bad. Straighten that up a little. Not good at straight lines. Okay, so what we're saying is if x is between -2 and 4, it's in this area right here. Okay, but I don't want to color it quite yet. I want to come back to that in just a minute. But we know that it's going to be in this in-between area. Let's look at the next one. Y is less than or equal to x plus 2. So this is already in slope-intercept form. We know how to graph this. We're going to come up here to our y-intercept. Okay, and then we're going to use our slope, which is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. We have an intersection point right here. I'm going to actually highlight that one so that it's red, because I think this one might be important since we're going to touch that line. We're going to do the same thing with this one while I've got the red out. And let's make the rest of them this green. So a few more points. And I can go ahead and start graphing that line. Okay, it is a straight solid line because it's less than or equal to. Okay, messed up that line. Okay, so less than or equal to is going on this side of the line. So we're already in between the two lines and on the lower half of this. And we also have these red points here that are going to be kind of important because those are like intersections. So we're just going to make sure that those are big enough that we can see them since I kind of covered over them a minute ago. Okay, and then our last line, y is greater than or equal to -1/2 x minus 3. You know what? I don't like how they wrote -1/2. We're going to write it so that we know what it means when we're looking at slope. Okay, so we have a y-intercept of -3, that's right down here. Why does it always do that? Okay, -3. We're going to go down 1 over 2. Down 1 over 2. I'll change that one to red in a minute. Down 1 over 2. So we've got our line going. Going to keep this up. Okay, up 1 over 2. All right, so we've got a bunch of lines here. I'm going to go ahead and connect my dots. That's terrible line dot connection. You guys like me though, so you'll forgive me. We've got a point right here where those connected. I think. Did those connect there? I'm going to count 1, 1. Well, yeah, it did. It does. It connects right here. This is the one I'm thinking of. I was just confused looking at it because my picture is messy. Draw better pictures and you won't be confused like me. We have an intersection here. So let's name those points of intersection. This one is 1, 2. So that's -2, 0. Okay, this one is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, 6. This point is -2, -2. Use that in a minute. And this one is 4, 1, 2, 3, 4, 5. 4, -5. Okay, so we have those points. And we're going to use them in just a second. So I'm going to erase some of this work. Actually, before I erase, let's go ahead and shade in the area that is our kind of area of concern. It's between these two lines, right? But it's also, so it's between the two sideways lines, and then it's less than this one, but greater than this one. So this is my area of interest. And what we're actually going to do is we're going to take this function that we haven't really talked about, and we're going to put the X and Y's that we got into this. So let me read these directions again so that you know what we've done. It says graph the system of inequalities, check. Name the coordinates of the vertices, check. Find the maximum and minimum values for this region. That's the thing we haven't done. And that maximum and minimum is going to be by plugging those X and Y's into this. So let me erase these other functions. We don't need those now that they're graphed. And so I'm just going to rewrite this equation F. Oops, let's use the bright green so you can see it better. F of X comma Y equals -2X plus 6Y. And the way we're going to do this is we are going to, I think it's easier to make a table. So that's my preference, but you can honestly, if you have a better way for your brain, that's fine. So I'm going to put the X, Y values down here. I'm going to put what is -2X plus 6Y right here. I'll show you what I mean by that. And then we're going to put the F of X comma Y. So let's do this first example. I'll show you what I'm talking about. Okay, so one of our points is -2, 0. Okay, so in this equation, I'm going to plug in the X and the Y. So -2 times X, which is -2, plus 6 times Y, which is 0. Okay, so this is -2 times -2, that's 4, +4, plus 6 times 0 is 0. So this is 4. That's what we're doing here. Let's do the next one. We did this one, -2, -2. I know it's hard for you to read it on my graph. Hopefully you wrote it as we were doing it. So we're going to plug that in. -2 times -2, that's +4, plus 6 times -2. So we basically have 4 minus 12, which is -8. All right, next point, 4, -5. So same thing, -2 times 4 plus 6 times negative 5. So negative 2 times 4 is negative 8. 6 times negative 5 is negative 30. We got negative 38. And then last point is 4 comma 6. So negative 2 times 4 plus 6 times 6. That's negative 8 plus 36, which is positive 28. Okay, so we've made our table by plugging in these different XY coordinates. And now the question is, what is our minimum and maximum? So our minimum is whatever the smallest number is, okay, which is negative 38. Okay. Our max is, what's the highest number? 28. Okay, and the minimum occurs at 0.4, negative 5. The max occurs at 0.4 comma 6. And I got that by reading across. So my negative 38 came from this point. My positive 28 came from this point. Okay, so that's the basics of how to do these problems. I know the why is also important, but I think you'll be bored if I explain it. And so I would prefer for you to read that in your book. I want you to try some of these problems. This is really all there is in this lesson, is how to do these problems and what happens in tricky situations. Like if there is no, maybe there's not a minimum, maybe there's a max but no min, maybe there's a max min but no max. Maybe there's no solution. So there's a couple of examples that you can look at. Definitely, if you have questions, please, please, please ask. But yeah, that's all there is to this, is just following these kinds of steps. Okay.